Hello everyone, good afternoon. I am Sindhu Reddy and I am a PhD student at the University of Wyoming. Today I will be presenting our work on side channel attacks titled Hidden Reality, and this work was done in collaboration with researchers from University of Wyoming and Texas A&M University. So before getting ahead into the details of the attack, I would like to talk about usage of VR devices first. Today VR devices are used in a wide range of domains. For example, attending meetings in office conferences, medical trainings for medical applications within the school premises, and many, right? So shown here are some of the examples of VR devices being used in semi-public and public places. So this shows that VR devices are no longer confined to private spaces or just the homes, right? So now coming to the text entry is inevitable while using the VR devices. For example, while typing passwords or pins on the VR devices. Shown here are ways of typing on VR device. The first way is using the controller. The second method is using the hand tracking, where hand can be used in order to input or navigate or explore the VR space. So we now know that VR devices are no longer confined to like private places. So it is used in public places where people or other devices such as surveillance cameras are present. So does that mean that shouldn't we use the VR device in public at all? Is it even secure to type sensitive information or perform financial transactions on VR devices? Little bit work was done in this area or the question that I had asked, here I show the attacks by other researchers in hidden reality or the XR space. So the first work is I Know What You Enter on VR Gear. It's by the Ling et al. So their work requires the prior calibration of the stereo camera to record the videos while the user types, their work was very confined to predicting only passwords. Similarly, the key logging inference attack was again very specific to inferring the random text type, and it also requires the access to the motion sensors data. In addition, their model needs to be trained on the victims before even predicting or inferring the characters. The face mic, on the other hand, it infers the speaker's identification like gender and also what the speaker speaks. And the holologger is a side channel attack on XR, and it again infers the passwords. So here overall all of these attacks require access to the external motion sensors data, or it requires training on victims data. So do you think all of these are even practical to launch? So on the other hand, our model hidden reality attack can be launched on the go without the need to access any of the motion sensors data, and it does not require a specific training on victim as well. All that it requires is the video recording of the victim's hand gestures and a known or a guessed keyboard layout. Now I'll be presenting the steps involved in execution of the hidden reality attack model. So the first step is video recording, where the user's hand gestures are recorded while they perform typing on the VR devices. The second step is video pre-processing, where the video frames containing the non-typing operations are trimmed. The non-typing operations include user setting the user boundary or exploring the VR space. I'm sorry. Okay. The next step is hand landmarks tracking and localization. The recorded video contains both typing and non-typing hand, and the goal of the attacker is just to localize the typing hand in order to infer the text type. Similarly, the landmarks of interest in this attack is going to be 3, 4, 7, 8, which denotes the tips of the index and the thumb fingers. Now, click detection is the crucial step that allows the attacker to know whether a click has been made by the user or key has been entered or not. So, click detection is performed using pinch operation as shown here, where the thumb and the index fingertips are in close contact. So, utilizing this as the metric, we have created a distance d as a measure to identify the distance between the thumb and the index fingertips. Whenever the distance is at the least, it means the click was made. And another metric is speed. Generally, whenever user enters or clicks using a pinch operation, the user's hand will be mostly in the stationary state. So, using this again as exploiting this as again a feature, we utilized speed as a metric. The hand position contains the hand landmark points average. So, computing the distance between the hand position of the current frame with that of the neighboring frames, click can be detected. The next step is inferring the characters type. So, once the click location coordinates are determined, the click location coordinates are xn and yn. So, once we obtain this data, the minimum and the maximum in the x and y directions are obtained, which in turn leads to the guessing of the keyboard geometry. So, once the keyboard geometry is determined, 52 keys are mapped, which are equidistant. Exception is the space key. The left side image shows the keyboard geometry, guessed keyboard geometry, where the clicked landmark coordinates are mapped. The right side image shows the example of the candidate character generation. The star key denotes the hand location coordinates of the click made, and the equivalent distance is computed between the key centers and the hand location coordinates. So, the least distance will be obtained as the top guess. For example, in this case, B is the first guess made by the hidden reality attack model, followed by N, and so on and so forth. So, to evaluate the efficiency and efficacy of the hidden reality attack, we we conducted experiments and we did invite 42 volunteer participants after getting approval from the university's IRB. The demographic details of the volunteer participants, such as gender, age, is presented here. In addition, we also wanted to, we were actually curious to understand the user perception of security and privacy on VR devices, and hence we conducted a user survey. Shown here is the user questionnaire shared with the volunteer participants as a Google survey link. To evaluate the performance of the hidden reality attack model, we have identified the following threat scenarios. The first three scenarios are equivalent to typing PIN, password or graphical pattern in order to log into the VR device or user accounts. The fourth scenario is equivalent to typing email content which contains the sensitive information to the friends or family. The fifth scenario represents surfing or browsing the internet. Coming to the experimental results, the accuracy was computed as a ratio of the characters correctly inferred by the hidden reality attack model to that of the actual characters typed by the user. 90.5% of the characters in the browsing scenario was deciphered successfully by the hidden reality attack model in top 5 guesses. 75% of the password characters was decoded by the hidden reality attack model. And 50.88% in the top guess itself was, the characters was decoded by the hidden reality attack model, which means once I know majority of the characters, I can actually decode the text. Similarly, 95% of the PIN's characters were deciphered by the hidden reality attack model. Right side image shows the confusion matrix. And the diagonal value represents the average percentage value of the true positives of the characters typed. Here if you could see G and W has recorded low accuracy. This is because these keys are surrounded by more of the neighboring characters. Graphical lock pattern input accuracy is computed based on the number of attempts required to break into the device. In our experiments, the hidden reality attack model was able to successfully decode the graphical lock patterns within the first 3 attempts itself, and shown here are some of the examples of the graphical lock patterns chosen by the users. Here I present the summary of the user responses to the questions that were asked during the data collection activity. Around 80% of the users were not aware of the physical surroundings while they wear the VR device and are immersed in the VR environment. And 55% of the users were comfortable performing the financial transactions on VR devices. 39% of the users were comfortable considering hidden gestures as, hand gestures as the preferred input, and 95% of the users perceive that a VR device is secure to use and is safe against typing the sensitive information while somebody is present in the people or other devices are present in the physical surroundings. We propose the following countermeasures. The first one is the randomization techniques, where the keys are randomly the keys are randomly changed. However, this method suffers these usability issues. The second method is by choosing the passwords or pins, which has more neighbors. This is because in the results we have shown that hidden reality attack model has lower performance, which has more neighbors. And the third step is completely obscuring. Maybe we should put a physical boundary within ourselves such that the hands are not visible at all. Or maybe, just as a practical example, one can face towards the wall and then perform any financial transactions. Overall, hidden reality attack model exploits the hand gestures to infer the characters typed by the user. And our attack can be launched on the go without the need for any specific training, and also without any need to access to census data. So hidden reality attack model challenges the false sense of the user's perception on security on the VR devices, and hence we encourage the research community to build more stringent and security systems to safeguard the user's data and accounts. These are the references used in today's presentation, and thank you.